Then basically just working on getting more practice with the exponential functions that we started yesterday. Like I said, we're not really adding much more to it. It's just doing some different things with it. There will be like one other kind of little new thing that'll be pretty easy to do though. So first thing, there's a difference between these two words, rate and factor. In terms of when they're talking about an exponential function, they're both dealing with the part that's in the parentheses, okay? So if I have this problem here, it says Al has an account that is compounded annually and earns interest following the function f of x equals 750 times 1.045 to the x power. What is the rate that Al earns interest? So, who can tell me the rate that he's earning interest? Ford? 4.5%. So if it's asking you about the rate, what you're doing is you are taking that part in the parentheses and we're going to change it from a decimal to a percent. When you change from a decimal to a percent, you move the decimal spot 2 places to the right. So we would have 104.5%. To get the rate, which is what this asked for, you subtract 100. If it was a decay problem, you would subtract the whatever number you get here after you change it to a percent from 100, okay? Just, whichever one's bigger goes on top. So when we subtract, like you said, we get 4.5%. That is the rate. Okay? Everybody good with that? Problems we did yesterday, that's what we was asking. All right, so now this is almost essentially same type of question. This is a little bit different though. It's asking by what factor is Bob's investment increasing? So what we want to do, we're going to get our function. So we'd have f of x equals, we take the initial amount, and in the parentheses, we would add that to 100, right? Because it's increasing with interest. And we would change that to a decimal. So we'd have 105.6%. When I change it to the decimal, I move the decimal 2 spots to the left. So that's going to give me 1.056. And I got my x as an exponent. So everybody good with that function? So when it asks for the factor, what you're looking for is right there. So our factor in this problem is 1.056. So do you necessarily have to write the whole function in that case? No, but that was just showing you how that works, okay? So if it asks for the factor, what you're giving is the whole thing that's in the parentheses. If it asks for the rate, you're looking for the percent that it's increasing or decreasing. Everybody kind of follow on the difference? I mean, it's two very similar things that are looking very similar in a problem, okay? It's not anything difficult, it's just confusing. All right, so then the other thing we gotta be able to do is we have to be able to find exponential functions from a table. There are a couple ways you can do this. If you do it without Desmos, which I don't recommend, but you could be able to in some cases, you got to figure out what the y values are doing. So what's happening to these y values? Doubling. So what that means is my rate is going to be times 2. I'm going to have x as an exponent. Everybody good with that? What we need is the initial value. The initial value is when x equals 0. So if I'm doubling, going times 2 when I go this way, if I go up this way, I got to do the opposite, right? I got to divide by 2. So 8 divided by 2 will give me 4 as my initial value. There's our function. Everybody kind of follow how that worked? Like I said, I don't recommend doing this without Desmos in most cases. If you ever have to do it without Desmos, it's going to be something that's a little simpler like that. You know, if we were increasing by 5%, y'all wouldn't be able to tell that by looking at it. Or I wouldn't be able to, so y'all probably wouldn't either. So what we have to do instead, we used to have to write this like complex equation. Whoop, not superscript. We got y sub 1, you put a squiggle line, we would do ab to the x sub 1, and you had to remember to type that in. Desmos has changed how it works with the testing, so we don't have to type that in anymore. All we have to do is get the table. Once we have the table, we're going to enter it into Desmos, and Desmos is going to do the work for us. So if I go to Desmos, I hit the plus sign, make my table, I enter in my ordered pairs, in this case, with exponential functions, you probably do want to enter in the whole table. It'll just make sure it works a little bit better for you. Then, just like we did with linear functions, we're going to hit the button here that has the dots with the line through it. And what it does is it adds that regression line that we had before. And you can see it doesn't go right through those dots, does it? It shouldn't. What we're looking for is an exponential function. So we need to make a slight change where it says linear regression. You see one of the options there is exponential regression. So we need to click that. Now I have a line that goes right through those dots. I also have my equation, 4 times 2 to the x power, which is what we got before. Everybody follow how that works? So when they give you a table, you have to pay attention to what kind of function it says is in the table. If it's a linear function, you want to do the linear regression. If it's an exponential function, you want to do the exponential regression. And we're not there yet, but eventually we'll have quadratic ones also. So those will be the 3 that you'll see for Math 1. But the question itself, I've just put a table here, but the question should say what kind of function it is, okay? All right, let's try it out. Everybody try to find the exponential function for this table. All right, Chastity, what you got? Kinda. All right, so we got 4 times 1.5 to the x power. All right, everybody good on how we got that? Desmos does basically all the work for you. You just have to enter it in correctly and make sure that you're selecting the exponential regression. But otherwise, it takes care of it for you. Okay? Everybody go with that then? All right, go ahead and give this one a try. We got some bacteria in a lab. After n hours is modeled by that function there. We know how many are in the lab or in the population after 6 hours. Kyle? All right, so we got 6 hours. N is the number of hours. So that means we're putting 6 in for N. Now, when you do this on your calculator or on Desmos, you probably want to go ahead and just do that math there. So if we put 6 in, 6 minus 1 is 5. So we'd have 50 times 3 to the 5th power. And like you said, that's our 12,150. So same idea. We go on Desmos. We got 50 3 to the, you could even put it, well, you can't put it on Desmos. So like I said, you got to do the math there. Oh, you can? Oh, I just hit the wrong button. So you could also do the, I guess I got to hit down here probably. Oh, parentheses. See, there you go. Is everybody kind of following that? Yeah, if you put the parentheses on it, I guess it'll let you do that. Also, like I said, it's 6 minus 1. Y'all could do that pretty easily on your own and put the 5 up there, and that would work too. Any questions on that? I forget which one y'all said 36,450, but that means you just use the 6. You forgot about that minus 1 part of it. All right, try another one. We got a population of coyotes since 2010. Sari, 320 is correct. All right, so on this one, they give you our function. N is the years from 2010. So we'd have 10 times 2. Since it's looking for 2015, that's 5 years later. So you would put your 5 in. And like she said, that gives us 320. Okay? Any questions on that one? So I got a function there. It's modeling the population of a town X years since 2006. Which of those best describes what P of 9 would be? Sydney? No. Ford? B is correct. All right, so if we've got P of 9, that means 9 is going in for X. X is the number of years since 2006. So 9 years later is making 2015. So what that gives us when we put it in is our population of the town in 2015. The percent change, or the rate of change, is what's coming from the 1.03. The percent change would be 3%. The rate also still going to be 3%. The population of the town in 2006 is our initial value in this case, so that would be the A there, but B is our correct answer. Okay?